let's show you an example of how voltage can be used to determine the voltage of an actual device. For example, a battery. Right? So let's take our battery, and we have a casing for it. So we put the battery in there. And so let's say that we want to know what the voltage is of this particular D cell, as you see. Well, we're going to want to be able to connect this battery up with the multimeter itself. So let's investigate how to do that. So now we take a close look here. We see there are three different ports that we can connect to with our connectors of various sizes and colors. So the 10 amp, we'll come back to that later. COM means common, and you can see that this port here has various functions, and so you see the volts that you see, so that's the one that we want. So we want to be able to connect into both of these two so that we're ready to connect to either side of the battery, both sides of the battery, and determine a voltage. Now, in order to do that, using this particular casing, what comes in handy are what are known as gator clips. Right. Now, these gator clips can be attached to the ends of the connectors. Those clips can then be attached to the housing for the battery itself. Okay, so now we're ready to take our measurement. Another handy feature is that you can actually prop these up just for ease of use. Now, we were talking about being able to use the voltage functions here. And so I could turn, and you can see I'm at 600 volts, and I continue down, and you see when I get to the 200 volts, I'm getting a reading of 1.2, so I'm getting a reading to tenth of a volt. And another thing you want to make sure of is make sure, whenever you deal with the several labs involving circuitry, you want to make sure you have good connection everywhere. An indicator that you don't have good connection if you just simply don't get any reading at all. And so you have to discern, well, is that the material and, maybe the battery's dead? Is the multimeter not working itself? Or is it the connection that's improper? So I always suggest that you check the connections, maybe even using different wires if you have to. Okay, but let's keep dialing down and see what happens here. Alright, so let me get on in here. And so you see 1.30 when I get to the 20 volt setting, so we've picked up an extra decimal place of precision. And I go to 2 volts, and again another precision increase down to tenths, hundredths, thousandths of places. And so you see as I'm dialing down, like we were saying earlier, then that's increasing the precision. But what happens if I go to 200 millivolts? Notice the output says 1. That's an indicator that you have gone too low with your setting, in which case you want to back things back. So, 200 millivolts, we know that that would be 0.2 volts. And so our source is definitely more than 200 millivolts, so we have to dial back up. So the 2 volts would be the appropriate setting in this case. And as it turns out, coming from the manufacturer, whatever cell you're using, whether it's a D cell or a C cell, AA, AAA, they're all designated, at least initially, to be 1.5 volts. So in this case, we see that we're a little undercharged, but still useful for this lab. So in that way, we can record the proper precision